Trebuchet is used two different ways. There is man that is pulling the trebuchet instead of counterweight. The other one is basically the counterweight to launch their projectile. The counterweight trebuchet is the best to fling projectiles up to 350 pounds at enemies at high speeds. Disease-infected corps were used to make their enemies sick during a siege. This is a medieval form of biological warfare. The trebuchet is the most accurate and better than other catapults. The trebuchet is similar to a catapult, but it's using a counterweight to launch a projectile. A sling is where the projectile will be placed.
Our trebuchet is made out of PVC pipes. It is 40 by 70 by 150 centimeters. PVC pipes are 3 fourths, and we used 11 T's, 1 cross, and 8 elbows, which were all 3 fourths. Our pouch that's going to hold our projectile was made out of a pencil pouch. We cut it and sewed it into a shape of a diamond. The string that will be attached to our nail is 16 inches, and then the string that has loop at the end that will come off the nail is 18 inches.
We added an eye hook at the top over here, and we added an eye hook down here. So we're gonna put down this pouch over here, and we have this little clip that we added. That way we can lock it at an angle. There, right there. And for this string, we're gonna put it right here at the top, and we have a little plastic right here so that way it could kind of go like at an angle. And we have this string attached to the clip, and when you pull it, it will launch.
In order to begin your calculations, you have to find your average time and distance. To do that, you add up your top 3 times and divide it by 3. In our case, you get 2.4 seconds. Then you add up your top 3 distances and divide it by 3 to get 10.846 meters.
Our trebuchet launched projectile 10.846 meters in 2.4 seconds.
The information we have so far is x, which is a distance of 10.486 meters. We also have the overall time, which is 2.4 seconds. Step 1 is to find the velocity in the horizontal direction. To do so, you need to use the displacement formula, which is x equals v naught t plus 1/2 at squared. You cancel out the 1/2 at squared because gravity does not influence horizontal motion. Then we go and plug in the variables that we have, which we have distance, which is 10.846 equals, we don't have v naught, but we do have time, which is 2.4. Then we divide 2.4 on both sides to get v naught equals, v naught, which is also known as vx, equals 4.519. Step 2 is to find the time to reach maximum height. To do so, you take the overall time, which is 2.4, and divide it by 2 to get 1.2 seconds. Step 3 is find the velocity in vertical direction. To do that, you need to use the formula v equals vy plus at. We don't have a velocity, so it's 0. We're trying to find vy, so we leave it as that. Our acceleration is going to be -10 because we have gravity pushing against the projectile moving in a vertical motion. And our time is 1.2. Now you multiply -10 by 1.2 to get -12. Then you add 12 to both sides, cancels out, and your Vy equals 12. Step 4, find the velocity at an angle. So far from step 1 to step 3 we have y equals 12, which is the height, as the same as Vy equals 12 going up. Also we have Vx, which is 4.519 meters per second. Now we're trying to find the velocity going at an angle. To do so, we need to go back to geometry, which was the formula a squared plus b squared equals c squared. In this case, a squared is Vx squared plus Vy squared equals v squared. Vx, which is 4.519 squared plus 12 squared equals v squared. 4.519 squared equals 20.421 plus 12 squared is 144 equals v squared. We add them up, which is 164.421 equals velocity squared. We square both sides. The square root is v equals 12.82 meters per second. Step 5, find the angle. So right here, the opposite is the height, which we have 12. And the adjacent, it's the distance, which is 4.519. To find out the angle, the only formula that we could use is tangent equals opposite over adjacent. And our given ones is 12 over 4.519. In order to have data by itself, we do the inverse of tangent, which is tangent equals -1 to both sides. So data is by itself. Data equals 12 over 4.51, and data equals 69. Step 6, find the maximum height. So we use the formula y equals v naught t plus 1/2 at. 12 times 1.2 is 14.4 plus half of -10 equals -5 times 1.2 squared equals 14.4 plus -5 times 1.2 squared is -7.2. We subtract 14.4 minus 7.2 and your answer is 7.2 meters. So now we finished all the calculations first. So for step 1, our Vx, find the velocity of the horizontal, was 4.519. Or step 2, the maximum height was 1.2. Our velocity in vertical direction was 12 meters per second. Step 4, velocity at the angle was 12.82 meters per second. Step 5, our angle was 69. And finally, step 6, maximum height was 7.2.